Hello students, welcome back. We went through most of the important topics from section 1, but I left out these exponential equations. Now, these are not really the key exponential equations. These are just stepping stones to something for the next week, but it's a necessary step anyway. So let's talk about these. And these are more directly related to exponent rules than exponential functions. Still, these are worthy of consideration at this moment. Be warned, these are not the kind of problems you're going to see in exam level. These are too simple. These are just here for stepping stones. Okay, let's begin. First problem. Let's copy and paste and go from there. Do you see any similarity, any commonality between 3 and 81? More precisely speaking, can you re-express the right-hand side as base 3? Well, 81 is 3 to the 4th power, and it's in denominator, so this should be 3 to the negative 4th power. Do you see that? Let's take a bit bigger font. Now we have the same base 3, and then the powers are 2x minus 1 and 4 respectively, so we can get those two equal. 2x minus 1 is equal to 4, and from this I can find out the x value. 2x is equal to negative 3, x equal to negative 3 over 2. Did I do this right? Well, one way to check is to put this number in and run your calculator. So 3 to the 2 and the negative 3 halves minus 1. Did I put in right? Let's take a little bit bigger font so that you can see better. Is that right? Let's run it. And indeed, I get 1 over 81. Confirmed. So in short, if you take the same base, then you can compare the exponents. Now, if you have two different bases, then that'll require some further thinking, and that's something we are going to do next week. For now, let's consider simpler cases. I already said these are stepping stones, okay? All right. Okay, next problem. Again, let's take a bit bigger font. Okay, just like last time, do you see a relation between 2 and 4? You can rewrite this 4 as 2 squared. And then the right-hand side can be rewritten as the exponent rule, this rule in particular. You can multiply by the powers. 2 to the 2 times y plus 3. In other words, 2 to the 2y plus 6. Did I do this right? So here, I used the power rule, multiplied by the power, 2 times y plus 3. And then I multiplied it out, 2y plus 6. So comparing to the y power and to the 2y plus 6 power, I'm going to get y equal to 2y plus 6. And solving this equation, flip it to the other side, y minus 2y equals to 6. Y minus 2y, that's negative y. So that will be y equals negative 6. Is that the answer? Well, one way to check, 2 to the negative 6 power is 1 over 64. And 4 to the negative 6 plus 3, that's same, 1 over 64. So left hand side and right hand side are the same when y equals to -6, so all makes sense. So what did he do? We use some exponent rules and make sure we have the same base here and there. If you want solution here in this notebook, here's the solution. Same thing and same checking. Also, here's the solution, same thing and same checking. All these works for same basis. 3 and then 3, 2 and then 2. Finally, if we have two different bases, or even more than two different bases and so on, that's going to be a trickier issue, and most of the time, we're going to convert everything into the natural exponential, and that's something we are going to do next week. A bit too hard for now. It'll have to do about this level, at least for now.